Data synchronization in between multiple clients is a challenge. Hello and welcome to Code with Czar. I'm Czar. How are you doing? Welcome back to CodeNameK. Today, we're going to look into different data syncing strategies. We're going to look into a few data syncing methods, their advantages and disadvantages. Based on that discussion, I'm going to pick one for CodeNameK. For those new to the channel, I'm going to spend 30 seconds-ish to talk about what is Project K. If you are already familiar with it, feel free to jump to the next chapter. CodeNameK is a project that I'm building and sharing the process with you. It will have a desktop app, a phone app, and a web app to store the numbers, and it will use OneDrive as a backend storage to exchange data in between those clients. Check out the blueprint video for more details. And again, I'm working for Microsoft as a senior developer. This channel or this project has nothing to do with my job. However, my tech preference is biased, and I hope you know that. Now that those are out of the way, let's begin today's content by the data contract. In this project, I am going to use data contract or data module interactively, referring to the same thing. And that is a formal agreement between the app and the storage. It is important to have a level of understanding of the data contracts before we talk about syncing, because those are the payloads to be synced. Depends on the contract of the data, we might need to pick different syncing strategies for optimal results. This is just like in our daily life, you're going to use different types of transportation for different goods. So we need to understand what our goods look like. To identify the contracts needed, I will usually referencing back to the UI marks. For example, in the previous video, I shared with you the UI vision like this. It displays a series of savings over a period. Then the question is, to form up a UI like this, what is the data that is needed? In the view, the series is formed up with 4 dots. To properly locate a dot, we would need a time and a value. And then, the reason these 4 dots show up on the same chart is because they belong to savings. And that, I will define it as a category. So here's our data model. There are 2 types of data that's going to be stored. Data point and category. For a data point, it will be uniquely identified by ID. The data points records when and what's the value. At this moment, category only have one field, that is the ID, that happen to be the name of the category. Here, I picked the naming string as the ID for category on purpose, and I'll get back to it later. For now, let's complete the model. What is lacking at this moment is also very important. That is the relationship in between data point and the category. For our model, it is easy. It is one-to-many. That means one category could have multiple data points, but one data point could only belong to one category. And you'll see why is that important soon. Traditionally, when we build an application that mainly deals with data, we would use a central data source model. On the abstraction, CodeNameK would look like this. On the left, there would be the client of CodeNameK running on the user's PC. There might be a little bit cache on the client side, but conceptually, there's no data there. And on the right-hand side, in the data center, remotely, there would be a central database and a web API edge thing to allow the CRUD operations. So when we need to add a record, for example, the client actually just passing on the request to add it. The web API would do the work. And when there are multiple clients for the same user or different user, they would all go through the web API. From the database perspective, it is as if there is only one user, and that is the web API. For this model, the advantage is that since there's only one set of data, there's no data consistency issue. So the data is always in sync, it's guaranteed. However, it also comes with several disadvantages. Firstly, since the data center is in remote, it will require constant network connection. Secondly, as you can see from the chart, we need to have a host for the database, and then the host for the API. And if or when they are done, all the clients will stop working. The hosts become so important, and it becomes the point of failure. And third, since all the users store the data in the same database, it is a security plus privacy concern. Database leakage is going to have impact on multiple users. Well, another concern on the paper is that if the code isn't designed carefully enough, one user might be granted permission to access another user's data. But that's never going to happen to us, right? Because we are perfect coder. So that would only happen on paper. Maybe. Well, with one pro plus that many cons, I am looking into something different. In order to get rid of the requirement for constant connection, it needs the client to hold a complete set of the data. And once that is done, different users could use the different storage to exchange data in their own clients. And I call it Bring Your Own Storage, BYOS. For example, their desktop application sends data to their OneDrive, and then their mobile downloads data from their OneDrive. The beauty of that is all this happens within one account. In other words, there's no way for you to access data that belongs to someone else. And of course, like most of the solutions, there is a trade-off. The data sharing across users becomes a little bit more complex. For the sake of privacy, I think it's worth it. Okay, now let's take a look at how would CodeNameK run under a system like that. At the very beginning, the client will check the OneDrive to see if there's any existing database to sync down. Since there's nothing, CodeNameK client create its own database. We call it DB1. At some time, DB1 would be synced to OneDrive. Then here comes CodeNameK, the second instance, maybe a mobile client. It would do the same first step to pull down existing database. Now the user did some operations. Since there's a data change, database 1 become database 2. And then database 2 got right back to the OneDrive, and it is ready for another cycle. Things worked perfectly so far. Data is distributed. We addressed the privacy concern. Offline operations are supported. The central hosts are gone. Uploading and download single file is peasy easy. Oh, by the way, if you don't believe that, refer to my last video. There was a showcase to upload gigantic files with progress bar, and I will put a link to the right upper corner. Coming back to the pros of the system, this model could easily be implemented using single file database solution like SQLite. But because this is a single file, there are some disadvantages. The first one is still single failure point. Only this time, it is the file itself. If it somehow got cropped, good luck if there's no backup. Well, okay, we have multiple copies. We could always check for corruption before syncing data, and we could introduce features like auto backup. The risk of file corruption might be mitigated. But this next issue is really difficult to overcome. Frequently conflict. Let me show you what I mean. Everything starts the same. Empty OneDrive, brand new client, and the client creates its own version of the database. This is so far the same as it was. Now, let's change the sequence of what things happen. Assuming, before CodeNameK1 got a chance to upload the database, the same user fired up the mobile client, the client 2, it would create its own version of the database. At this moment, client 1 got a chance to upload the database. Still okay, but then client 2 starts to upload. Now remember, database 2 isn't built upon database 1. So if we take database 2 on OneDrive, data in database 1 would be missing. Vice versa, if we would take database 1. It would be a tough case, especially when you have a huge amount of data in both databases. Now let's think carefully. What is the cause for these issues? It's a single file. To overcome those issues, after analysis, I used another way to store the data. Here's the deal. The single file storage is causing trouble, so I'm looking for alternatives. That is something that can still store my data and across multiple files. I think you still remember. I mentioned it is important to understand the relationship in between the category and the data point. And this is why I am looking for another way to store data that has a one-to-many relationship. And I want to distribute the data into different files. Other than database, what could be used to represent a relationship between one-to-many? That is file 1, file 2, file 3, file 4, in the folder. Now, if one category maps to one folder, then the data points in it could be mapped to files inside a folder. Each file will have a global unique file name. The file contains content for the data point, like when it happened and what's the value. Now let's take a look at what would happen for the same scenario. At the very beginning, there's nothing on the client or on the OneDrive. Let's assume the user created 3 data points on client 1. All of them belongs to the same category of saving. It will end up having a saving folder which contains 3 files. To align the scenario, let's say before CodeNameK1 get a chance to upload any of those files into OneDrive, there comes CodeNameK2. On client 2, the user also created some other points. Out of those points, one also belongs to savings. The rest are in the category of exercise. Now client 1 starts to sync and finish uploading all the files. And then it's client 2's turn. Since all the file names are globally unique, there's going to be no conflict for the files. You probably also noticed all the data in the same category has been merged automatically. And that's why I picked the category name as its ID. It also maps to the reality that if 2 categories have the same name, it's the same category. The end result is going to be 2 folders, saving and exercises. Each, respectively, have 4 files and 2 files. And that's distributed file syncing. Compared to the whole file syncing, let's go over the pros and cons. The data is still distributed, bring your own storage is still supported. So first item, check. Support offline operations, check. No central host requirements, check. Since this is not a single file any further, it will lose the simplicity of single file syncing, and there is not a RDBMS system that I am aware of that supports this kind of storage. It will overcome the disadvantages of file corruption. It will reduce the chance of conflicts. There are, although, some other disadvantages. When you have too many files to sync, the time to establish a connection for file transportation might become something costly. And without a mature RDBMS support, it might require more effort to implement advanced features like transactional operations, indexing, etc. etc. Yeah, that's a reality. For complex problems like data syncing, I don't believe there's one solution fit for all. I don't even believe there's a perfect solution. But in case you do, comment below to let me know. Actually, any suggestions are welcome. So we talked about central data source, whole file syncing, and distributed file syncing today. For CodeNameK, you probably guessed I'm going to take the distributed file syncing solution, and I do have more to talk around it. But hey, what would you choose, and why? Feel free to comment below to let us know. And if you like the topic, don't forget to subscribe. Keep coding, keep improving, and I'll see you in the next one. Until then, take care.